Dear students, good morning. Again, we are going to continue chapter 2nd, units and measurement, that is second part. Yesterday we had discussed about physical quantities. We had defined physical quantities. We had given a brief idea about physics and what is the need for measurement in physics. We had defined physical quantities, what are called physical quantities, what is the need for the measurement of physical quantities. As we had discussed, physical quantities, physical quantities. Physical quantities has three characteristics. First characteristic, that is its numerical value. Numerical value only. And this numerical value consists of ratio, that is refractive index, dielectric constant, etc. Or second one is magnitude only. Magnitude only means numerical values, that there is a difference between numerical value and magnitude. In a numerical value, it is not necessary that its unit is mentioned, but in magnitude, while writing the magnitude for a physical quantity, we have to write the numerical value along with its units. So this is the difference between numerical value and magnitude. And it is also called as a scalar. Example: mass, charge, current, etc. And the third one is, that is magnitude along with direction. Magnitude and direction. Magnitude and direction only. And in this, the physical quantities which we mention are displacement, velocity, torque, etc. So we can say that there are the three characteristics of physical quantities. There are various physical quantities where there is no any need of any unit, and that are simply the ratios. Just as a refractive index are the ratio of two same physical quantities, so it has no any unit, and it can be represented only by its numerical value. Dielectric constant is also a constant quantity which has no any unit. Similarly, the magnitude only, or you can say that a scalar, that quantities have numerical values along with its unit. And the examples are mass, charge, current, etc. Mass is represented in kilogram, charge is represented with coulomb, current is represented with ampere. These are the units to specify that physical quantities. And the third one is the magnitude as well as direction. The various physical quantities such as displacement, where there is the need of magnitude, that is need of numerical value along with its unit means magnitude along with direction. 3 meter towards east, 3 meter per second towards west. So these are the physical quantities in which there is magnitude as well as direction. So these are the three specifications for physical quantities. Now there are certain physical quantities in which there is no need of a specification of magnitude and direction. Magnitude and direction are not only the parameter to specify that physical quantity, and that physical quantities are called as tensor quantities. So note it down. The physical quantities which are not completely specified even by magnitude or units or direction. These physical quantities are called tensors. These physical quantities are called as tensors. Means the physical quantities in which not even magnitude, its units and directions are completely specifying the physical quantities. That quantities are not included in either in a scalar or in vector. They are called as tensors. Tensors which are no needed to be studied quite in detail. We have to study later on only about scalars and vectors. The example of tensors I am giving. Example, moment of inertia. Moment of inertia is a rotational analog of mass, and it is only specified as tensor quantities. So magnitude of a physical quantity, magnitude of a physical quantity is equal to numerical value into unit. In short, we can write it as N U. N is for numerical value and U is for unit. Now note it down. As unit of a physical quantity changes, its numerical value also changes, such that the physical quantity always remains constant. If numerical value changes, its unit also changes, so that the value of physical quantity remains constant. Example. For example, we can say that we can write it as 1 kilogram. It is equal to 1000 gram. Here what you are observing? You are observing that in the left side I had written, left side of the equal to sign I had written 1 kilogram. So 1 kilogram is equal to 1000 gram. So suppose this is N1, this is U1 is equal to N2 U2. Both things are equal. It means to say that if we are increasing N1, then U1 is going to be decreased, so that it will always remains constant. Always remains constant. And from here we can say that numerical value is inversely proportional to its unit. Numerical value is always proportional to its unit. Similarly, for density of water, I am writing here in two different units. Density of water. Density of water. Density of water, it can be written in 1 gram per centimeter cube, and it is equal to 10 to the power 3 kg per meter cube. 10 to the power 3 kg per meter cube. So you are seeing that we had converted 1 gram per centimeter cube is equal to 10 to the power 3 kg per meter cube. Means if we are changing the units, the numerical values is also going to be changed. It can't be written as 1 kg per meter cube. This is the wrong statement. Second thing, one ampere is equal to 1/10 EMU of current. Electromagnetic unit. This is what? Electromagnetic unit of current. Electromagnetic unit of current. This is electromagnetic unit of 1 ampere is equal to 1/10 EMU. Here look at here, 1 is greater than 1/10. It means to say that ampere is the smaller unit and EMU is the greater unit of current, and this is also called as watt. This is also called as 1. So this is all about the physical quantities and how the magnitude of the physical quantities can be expressed in different numerical values and different units. Now, regarding magnitude of the physical quantity, we want to discuss about the magnitude of the physical quantity. Magnitude. Magnitude of the physical quantity. As you know that in physics, we discuss the very large quantities just as size of the universe to very small objects, that is size of the nucleus. Mass of electron, and I am taking a smaller mass of electron, that is equal to 9.1 into 10 to the power minus 31 kg, and mass of sun, that is equal to 2 into 10 to the power 30 kg. Now look at here, from what is the range of measurement in case of physics. In the range of measurement in case of physics, that we are measuring the mass in 9 point so much a smaller mass to so much bigger mass. This is a wide range for the measurement of magnitude of masses or physical quantity. Similarly, other quantities also, as I am discussing about the mass, time scale, length scale, in all the scales we measure very smaller part to very larger part. So for the measurement of this large range of measurements, we use certain prefixes. So I am listing here some prefixes. Note it down. Power of 10, prefix and symbol. Ten to the power 18, that is called as exa. 10 to the power 15, eta. 10 to the power 12, tera. 10 to the power 9, giga. 10 to the power 6, mega. 10 to the power 3, kilo. 10 to the power 2, hecto. 10 to the power 1, deca. 10 to the power minus 1, deci. 10 to the power minus 2, centi. 10 to the power minus 3, milli. 10 to the power minus 6, micro. Mu, just like micro, mu. 10 to the power minus 9, nano. 10 to the power minus 12, pico. 10 to the power minus 15 femto, 10 to the power minus 18 auto. Okay. So these are the prefixes which we use in the case of measurement of physical quantities. There are certain conditions for the use of these prefixes. So we are discussing the conditions for the use of these prefixes before the measured value. Before the measured value. So first one is double prefixes should be avoided. Double prefixes should be avoided. What is the meaning of this? Double prefixes should be avoided. Microfarad. It is wrong. It can be written as picofarad. Megawatt. It is wrong. It can be written as gigawatt. Second thing, kilometer cube. It means to write it as 10 to the power 3 meter cube. This is the correct one, but 10 to the power 3 meter whole cube. This is wrong. Microsecond inverse. It can be written as 10 to the power minus 6 second inverse. This is correct. It is not. Means you cannot write these units in the bracket and the whole power is given by as the power given in the previous unit. It is not written like that. It is the wrong way to express. This is the right way to express it. Five into 10 to the power minus 6 farad. It can be written as 5 microfarad. 1.3 into 10 to the power 6 electron volt. It can be written as 1.3 mega electron volt. Now, in the next video, we will discuss about what are the magnitude. While writing the magnitude of the physical quantities, what precautions we kept in mind, and after that we will solve certain numericals and move to the next topic. Thank you, students.